All right, now we're going to talk about section 3.3, which is on completing the square. I'm not sure if you guys have ever seen this before, so you might want to take pretty good notes on my examples that I'm going to use. So, let's see if I can adjust that a little bit. So let's say we have this quadratic equation, and if you are really good at factoring and you really remember Algebra 1, you're going to recognize that this is a perfect trinomial square. And we all know that 100 is a perfect square, so I'm going to solve this using square roots, just to show you how easy it is to solve these if this is a perfect trinomial square. And when you factor that trinomial square, you're going to get x minus 8 times x minus 8. In other words, the quantity x minus 8 squared. All right, so if you take the square root of both sides of that equation, you end up with x minus 8 equals plus or minus the square root of 100, which is 10. And adding 8 to both sides, we're going to get x equals either positive 10 plus 8, which is 18, or negative 10 plus 8, which is negative 2. So the answers are negative 2 and positive 18. Well, not all of our quadratic equations are going to be nice trinomial squares like this, so we're going to do completing the square to make it so. Alright, so we'll just start off with a couple of examples. So you have x squared minus 10x plus 7, and I can see that this is not a perfect trinomial square because, first of all, 7 is a prime number. So here's the process. We're going to put this constant on the other side so that all I have left on the left are my two x terms, all right? And personally, I think it's easier to do completing the square if you actually put plus and put a blank here, put plus and a blank here, because I'm going to add something to this to make this a trinomial square. And remember, I can do whatever I want to an equation. If I add something over here, though, I have to add the same thing over here. So, how do we determine what goes here? So, here's a quick Algebra 1 refresher. This is going to be a perfect trinomial square if I take half of this term and then square it. Half of this term is 5. 5 squared is 25. So I'm going to add 25 to make that a perfect trinomial square. And don't forget, whatever I add here, I have to add there as well. That thing's falling apart here. Okay. And why did I do that? I did that so that I can factor it this way. And now I can solve this equation by using square roots. If I took the square root of both sides of that equation, I get x minus 5 equals plus or minus the square root of 18. I know there's a perfect square in there, so I'm going to, well, first of all, let's add 5 to both sides, so I get x by itself. 18 is really 9 times 2, right? And 9 is a perfect square. So if I take that square root of 9 out of there, the square root of 9 is 3. I'm going to take that out and write down whatever's left over. Remember, I want this constant listed first. This looks better. So I end up with 5 plus or minus 3 times the square root of 2. And those are my two solutions. Let's do another one. All right. 3x squared plus 12x plus 15. I can see that this is not a trinomial square. This is not a perfect square, neither is this. I'm going to wait for my cat to walk across the keyboard. And then also note that all of these terms can be divided by 3. So if I factor a 3 out of that, I end up with x squared plus 4x plus 5. I've just divided every single thing in there by 3 to simplify this a little bit. Okay, you get your constant on the other side, so I'd have x squared plus 4x equals negative 5. And I know I'm going to add something here that makes this a perfect trinomial square. So you take half of this term, which is 2, and then you square it. So to make that a trinomial square, I'd have to add 4 there. If I add 4 there, I have to do it to the other side. Alright? And remember, the reason for completing the square is so that it's easy to factor. Negative 5 plus 4 is negative 1. The opposite of squaring something is taking the square root of both sides. Like that. The square root of this is x plus 2. And then I'd have plus or minus the square root of negative 1. But let's not forget, we know what the square root of negative 1 is. The square root of negative 1 is I. So in other words, this quadratic function does not cross the x-axis because the two solutions are imaginary numbers. And that is it. No, it's not. We're going to do some word problems. Because that's everybody's favorite, right? Alright, so here's your problem. The height and feet of a baseball t seconds after it's hit is modeled by the function negative 16t squared plus 96t plus 3. This is the height. T is seconds after it's hit. So we want to find the maximum height of the baseball. And we also want to know, so here's the first part that we're going to do, find the maximum height of the baseball. And then the second part is, how long does it take for the ball to hit the ground? Let's do that first part first. So if I want to find the maximum height of the baseball, remember this is a parabola that looks like this. The maximum height is right here. It's going to be the y value of my vertex. So if I can find the vertex, I can find the y value of the vertex is going to be the maximum height of the ball. So I'm going to go ahead and put this in vertex form. And I'm not sure that we've done this in class yet, going from standard form to vertex form, but I'm going to show you how to do that. So I'm only going to concentrate, first of all, on these two terms right here. And I know that 16 is a common factor between these two terms. If I divide out, factor out a negative 16, what I have left here is t minus 6t. It might be helpful if you work along at the same time and then pause the video if you need to watch the steps that I go through to solve this. And then I have this plus 3 on the outside. Okay. And now I'm going to complete the square on this part. Alright, so I'm going to take half of 6, which is 3. 3 squared is 9. But remember, I'm not really adding 9 over here. I'm adding 9 times negative 16. So that's what I have to add to the left-hand side. 9 times negative 16, which is negative 144. Alright? So, but I don't want this over here. I'm going to have to add it to the other side so that it looks like it's the correct form for the vertex form. So now I've got this quadratic equation for this problem in vertex form. And I know in vertex form that h is 3 and k is 147. So that's my vertex, right? Well, remember that the maximum value of this parabola is the y value of the vertex. So the maximum height that this particular baseball gets when you hit it, or when it's hit, is 147 feet. So that's part A. Remember that part B was how long does it take for the ball to hit the ground. In other words, solve for t when y is 0. I want to find out the solution. Okay, so I'm going to go back to my vertex form, which I found right there. And I want to isolate this part. So in order to do that, I'm going to subtract 147 from both sides to get this. And then I'm going to divide both sides by negative 16. And when I do that, I get this right here. And to solve this, I'm going to take the square root of both sides to give me that. I want to get t by itself, so I'm going to add 3 to both sides. So I either have 3 plus the square root of 9.1875, or I have 3 minus the square root of that. Well, we can reject the 3 minus part because this answer is going to give me a negative number. And there's no such thing as negative seconds. So this is the only part that we're going to have to worry about for our answer because it's the only part that's going to give me a positive answer. And if you do this on your calculator, you get approximately 6 seconds for the ball to hit the ground. And that's it for 3.3.